when it comes to graphing functions, you also need to determine if a function has an asymptote. The two types of asymptotes that you want to look for are your vertical or your horizontal asymptotes. Let's look at how to find a vertical asymptote. So always factor the function as far as you possibly can. If the denominator has a 0 at x equals a, then that becomes your vertical asymptote, your equation of your vertical asymptote, provided that the numerator does not have this as a 0. And ultimately, you want to just observe the behavior of the curve as y approaches infinity and y approaches negative infinity. So let's look at this example here. Look for the 0 that's in the denominator. So if you equate the denominator to 0, you see that x equals minus 2 is the value of x that makes the denominator 0. And so this becomes the equation of your vertical asymptote. We can also look at the behavior of the function as y approaches infinity and y approaches negative infinity. If we make x the subject of our function, so we'll just do that on the side over here. So what I'm going to do is I'm going to flip both sides. The left-hand side is 1 over fx, and the right-hand side is x plus 2 over negative 1. We're trying to make x the subject here, so I'll multiply both sides by that negative 2, and we'll subtract this 2 to both sides. So this is the equation with x as the subject. As fx approaches infinity, or y approaches infinity, what you will see is that x approaches negative 2. That's because this part of the function here approaches 0, because you're going to have negative 2 over a really big number, infinity, making this 0. And so all we're left with is this minus 2 over here. So x approaches minus 2. And as fx approaches negative infinity, x is also going to approach minus 2. It's the same situation. So that confirms that this, or x minus 2, is our vertical asymptote. Now let's look at how to find a horizontal asymptote. So you want to divide the top and the bottom by the highest power of x in the denominator. And we use the fact that 1 over x approaches 0 as x approaches infinity and as x approaches negative infinity. So similar to the ID that we utilized in the previous example. And then we also want to observe the behavior of the curve as x approaches infinity and negative infinity. So if we have a look at this example, the first thing we're going to do is divide by the highest power of x. The highest power of x is x to the power of 1. So we're going to divide each term by x to the power of 1. So x over x becomes 1. This is 1 over x. X over x is 1, and this is 4 over x. Now both of these, as x approaches infinity and negative infinity, both of these are going to approach 0. Once again, because when you have 1 over infinity, that approaches 0. And 4 over infinity is the same thing as 1 over infinity. It's just 4 times 1 over infinity. So that still approaches 0. So these are going to approach 0, meaning that what we're left with is 1 over 1, which equals 1. So this is going to have horizontal asymptote at y equals 1.